The last part of 5.3 is focusing more on technology usage than doing things by hand. So we've talked a lot about how when we are solving polynomials, what the answers that we are finding those places where the graph crosses the x-axis. We're finding those solutions that we visually can see. Any type of real solutions, there will be a visual evidence of what's going on. So I want to look at ones that you can't factor, ones that you don't have the ability to use other techniques that we've learned, where you have to be relying on the calculator to solve. So I want to show you a couple options. I will tell you the option after I show you the two that I believe is probably the easiest for you, but I do want to give you options. So you want to have your calculator close by so we can type some things into our calculator and talk about different ways to solve polynomial equations using a calculator. So all you're going to see for directions is it's going to ask you to find the real solutions of an equation. It will indicate that you will need to use a calculator. Like I'd like to put that in the question, like using technology or using your calculator. It will also tell you about rounding. So if rounding is necessary, how to round. I've been trying to stick with like rounding the nearest decimal place, rounding the nearest tenth. You will have ones that you don't need to round that will be whole numbers. So when you have something like this, you have two options. One option on your calculator is to look at each side of the equal sign as a separate part of this equation. So thinking of like this part as part one and this side as part two. And so when you go to your calculator and you go to your y equals and get rid of whatever's there, you're going to type in one side of the equal sign into one of the lines. So just in y1, I'm going to type in x to the third power plus 5. And then into y2, I'm going to type in 4x to the second power plus x. When I go to graph, I'm going to hit zoom 6 just to make sure my screen is on a standard window, 10 by 10. That's going to be the first thing you typed in. And that's going to be the second thing you typed in. So you get a cubic function is the first thing you typed in, and then you get a quadratic, a parabola is the second one. When you type it in like this, you are trying to look to see where the graphs intersect. So you're looking for what's called the intersection of these. That's what's going to tell you when these two equations are equal, when they intersect. Just like when we did systems of equations back with lines. When they intersected, that's when they were equal to each other. So on your calculator, if you go to the calculate menu, which we've been to many times now, you hit second and trace. This is the calculate menu. We're going to use it more today. You'll notice that one of the buttons says intersect. We've actually done this in class before. If you go down to number 5 or just hit number 5, it's going to ask you which curves do you want to see where they intersect. Well, there's only 2 curves here. So if you hit enter 3 times, enter, 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 it's going to give you an intersection point. I am only worried about the x values because when I'm solving, I'm looking for the x values. And I can see that I have an intersection of 1.16, or if I go to one decimal place, like 1.2. Well, here's the issue. That's not the only place they intersect. So if I want to continue to find the solutions, I have to go through that process again and hit second and trace and intersect. Now I want to move my cursor. So I'm going to use my left arrow and I'm going to move the cursor over. And I want to go closer to where they intersect over here. You'll notice you can see that intersection here. Now I want to hit enter, enter, enter. So hit enter 3 times. And it tells me that they intersect at about negative 1.09 or negative 1.1. Here's the issue with this technique, and I will say of the 2 techniques I'm going to show you, this is not my favorite. I actually like the other one better. I'm going to spend way more time on it. They actually intersect again. So I have a graphic on the next slide so you can see this. So this is what I'm doing here. I'm finding those intersections, and you can see in this top row of pictures, I have an intersection, the negative 1.09, the 1.16 is the middle picture. The problem is, if I actually go out further, they do intersect another time, but your window has to be so big to see it, you would have to adjust it, that very likely you wouldn't even notice that it happens. Because while it happens at a pretty small x value, like 3.9, it happens at a really high y value. It's over 65, which our window is only set in a standard window to go up 10. So here's how we do this. Obviously, you can adjust your window as much as you want and go like that. But I actually think there is a better method, and that better method is kind of what I'm going to illustrate here in method 2. The better method, in my mind, I'm going to go back to what I just did. Instead of immediately starting out by putting one equation in y1 and one equation in y2, is get it in standard form. So standard form was that everything was on one side equal to 0. So if I do x to the third, I'm going to bring the 4x squared over, so minus 4x squared. I'm going to bring the x over, so minus x plus 5. Now when you go to your calculator and go to your y equals, get rid of what we just typed in there. Now I want you to type in everything here. Now that you have it equal to 0, you're going to type in x to the third minus 4x squared. Just make sure you type it in right. It's so easy to miss a sign or miss a button. Plus 5. You don't need to type in the equal 0. You're just going to type everything up until the equal sign. Hit graph. You have a very different looking picture. But now what you're doing, since now you have it equal to 0, you are looking for the places on your graph where it hits the x-axis, because that's when it equals 0. So what you're doing, and I'm going to kind of highlight my calculator a little bit, is you are looking for these values. You're looking for these x values where it crosses the x-axis. So we've done this on our calculator before. This is something that you have seen. To do this, you're going to go to the same menu, calculate menu, second trace. You're going to go to the 0 button, because that's what you're trying to find. When does this equal 0? Now, when you use the 0 button, you are going to have to move your cursor, and you're going to use the left arrow and the right arrow to do that. I like to do them from left to right. So I'm here, my first 0. I want to make sure my cursor is before it crosses the x-axis and hit enter. And then I want to go through the x-axis, hit enter, and then hit enter one more time. And it's going to tell you at the bottom of the screen where that x value is, and you're going to want to jot it down because you are, or just get ready to type it right into Delta Math. We're going to say it's about negative 1.1. So there's one of my answers. Go back to my calculator. Now I'm going to do the same thing. Second trace, 0. So now I'm going to move my cursor over before it crosses the x-axis again, hit enter, go through the axis, hit enter, and then enter one more time. And my second answer, 1.16 or 1.2 if we go 2 decimal places, or 1 decimal place, excuse me. And then I've got one more, so I do second trace, 0. And I'm going to move my cursor a little bit more before it crosses the x-axis. Right there's fine, enter, through the x-axis, enter, enter. And that one that was really hard to see doing it the first way I showed you is so much easier to see now. It is about 3.9. And there are your answers. And when you enter it in Delta Math, you're going to enter them in. It doesn't matter the order you enter them in, but you are going to enter them as separate numbers. You'll have to hit the little plus sign on Delta Math to get another answer blank to fill it in. But that's what you're doing. And I will tell you how many solutions, just so you're not wondering if you have them all. I will put on Delta Math that something like you have 3 solutions or 2 solutions or 4 solutions, so you know you have enough before you submit your answer. So let me just take you through a couple more, and then we will be good with this last topic. So here again, here's one that we want to find the solutions. Again, I personally think it's easier to get everything on one side. I think when you're dealing with really simple equations, that intersect feature is nice, especially if you're just dealing with 2 like linear equations. When you start dealing with higher powers, it becomes just so hard to read the calculator and make sure that you're looking at a good window. All right, so I'm going to go to y equals. I'm going to type in my equation, so x cubed plus x squared minus x plus 1, and I'm going to hit graph. I'm also going to make sure we stick with ones that are very easy to see in a basic window. So here's what you'll notice on this one. This one only has one solution. You'll notice the graph never comes back down. This should not be surprising. It is an odd function, and odd functions have opposite end behavior. So this one's going down on the left, up on the right. So it's never going to turn around and come back down. If I go to second trace and I hit 0, I'm going to go through, there we go, before it crosses the axis, enter, through the axis, enter, enter. We have one answer, and it's about negative 1.8. Negative 1.8. I want to show you one more, just because this actually happens a lot on the Delta Math ones, and if I can save yourself some time and energy, that would be great. So this one, I want to get it in standard form. So I have 2x to the 4th minus 5x to the 3rd minus 3x squared. And before I grab a calculator, I want to show you something that happens in this one that is very common. If you notice with this one, all of your terms have a GCF. They all have an x squared. If you notice that, especially if you notice everything can have an x taken out or everything can make an x squared taken out, it's going to make it easier to work with the calculator, and it's going to make it easier to find one of the answers. So I'm going to take out that x squared. This is what I'm left with. This, I already know the solution. I know the solution that comes from this is 0. So instead of typing this whole thing into your calculator, you can actually make it much easier on yourself and just type this into your calculator, since you already know the solutions with when you pull an x squared out. I mentioned that because you're going to see it on Delta Math, and by doing that, it's going to make it easier on the calculator, and it's also going to make it easier just to find your answers. So I'm going to go to y equals. I'm going to get rid of that. I'm going to type in 2x squared minus 5x minus 3 and hit graph. It's going to be a parabola, which is going to be very easy to read. It has two solutions, two places it crosses the x-axis, so I'm going to have to find them both. So second trace, 0. I'm going to go before it crosses, hit enter. After it crosses, hit enter, enter. You get negative 0.5, which you can write in as a decimal or a fraction. I think I wrote on for this in Delta Math, I just stuck with all decimals since that's what the calculator gives you. And then second trace, do the same thing. 0. I'm going to go before it crosses the x-axis here and then work my way through the x-axis, enter, enter. And my other solution is 3. So I have 3 solutions. I'm going to put those into my calculator in any order, and those are the solutions of my equations. So I want to show you your options. I want to show you how to use your calculator, and I definitely want to show you one like this, because if you can do that and get 0 as one of your solutions, the graph is going to be easier to read and it's going to be easier to find the other answers. So that is the last part of 5.3, using a piece of technology, calculator, Desmo, something like that, to be able to find solutions of polynomial equations.